Every single dot of light you are looking at right now, it is not a star, it is an entire galaxy. Each one containing hundreds of billions of stars, each one potentially containing billions of planets. And this image, this single photography was taken in a patch of sky roughly the size of a grain of sand held at arm's length. We are not alone in this universe. The mathematics makes that almost certain. But for the first time in human history, we now have a telescope powerful enough to actually start looking for the answer. The James Webb Space Telescope, $10 billion, 25 years in development, the most complex scientific instrument ever built by human hands. And what it has found in just the first 2 years of operation has forced scientists to rewrite what they thought they knew about the universe. Before we get to the discoveries, you need to understand what this telescope actually is. Because the James Webb is not just a bigger, better version of the Hubble Space Telescope. It is an entirely different class of instrument. Hubble orbits Earth at about 570 kilometers above the surface. James Webb doesn't orbit Earth at all. It sits 1.5 million kilometers away, at gravitational sweet spot between the Earth and the Sun called the L2 Lagrange point. At this location it stays permanently in Earth's shadows, protected from the Sun's heat and light. Because here is the thing, James Webb doesn't photograph visible light the way Hubble does. James Webb photographies infrared light, heat signature, light that is invisible to the human eye, and that distinction changes everything. When light travels across billions of light years of expanding universe, its wavelength stretch shifting from visible light into infrared. Hubble couldn't see it. James Webb can. James Webb operates at temperature of minus 266 degrees Celsius. This is just 6 degrees above absolutely zero, the coldest temperature physically possible in the universe. Its primary mirror, 6.5 meters wide, made of 18 gold-plated hexagonal segments, has a focal length of 131.4 meters. For context, a professional camera lens typically has a focal length of 50 millimeters. James Webb is 131,400 millimeters. It is in every measurable sense the most powerful eye humanity has ever pointed at the sky, and in 2022 it opened for the first time. On July 12, 2022, NASA released the first full-color images from the James Webb Space Telescope. The reaction from the scientific community was not excitement, it was shock. The first image, James Webb's first deep field, showed thousands of galaxies in breathtaking detail. Some of them are so far away that the light we are seeing left them 13.1 billion years ago. The universe itself is only 13.8 billion years old. We are looking at galaxies that formed just 700 million years after the Big Bang. When you look at that image, you are not looking at space, you are looking at time. But what made this image even more extraordinary was a phenomenon called gravitational lensing. The galaxies in the foreground are so massive, containing so much gravity that they beyond the light coming from the galaxies behind them. They act as a neutral, magnified glasses built into the fabric of the space itself. James Webb used this effect to see objects that would otherwise be completely invisible. Galaxies behind galaxies behind galaxies. It took 12.5 hours of combined exposure to create that single image. It covered an area of the sky the size of a grain of sand held at arm's length. It contained thousands of entire galaxies. Multiply that across the entire sky, and the number of galaxies in the observable universe is not billions. It is closer to trillion galaxies, each one a universe unto itself. Here is where the story stops being just beautiful. It starts being genuinely alarming to scientists. When James Webb began photographing the early universe, the universe as it exists just a few hundreds millions years after the Big Bang, it found galaxies. That was expected. What was not expected was the size of those galaxies. In 2023, a bombshell study published in journal Nature identified six massive galaxies from the early universe, each one the roughly size of our own Milky Way, but they existed from just 500 to 700 million years after the Big Bang. According to every cosmological model we had galaxies that large simply can't form that quickly. It takes billions of years for enough matter to gravitationally collapse into structures that big. But there they were. Astronomer Lebo Lobe of Swinburne University, who led the research, described it bluntly. He said that if even one of these galaxies is confirmed at the size of James Webb is detecting, our entire model of how the early universe formed needs to be considered, not tweaked, not adjusted, reconsidered. This is what James Webb is doing to cosmology, not confirming what we thought we knew, challenging it. Every time scientists point this telescope at a new corner of the sky, it returns data that raise more questions than it answers. And that, in sense, is the most exciting thing that can happen. Beyond the deep universe, James Webb is doing something even more immediately scientific. It is looking for light, not directly, not through photographies, through a technique called transmission spectroscopy. When a planet passes in front of its star, some of the star's light filters through the planet's atmosphere. Different molecules absorb different specific wavelengths of that light. Water absorbs certain wavelengths, methane absorbs others, carbon dioxide others still. James Webb spectrograph can detect exactly which wavelengths are being absorbed and found that identified precisely which molecules are present in the planet's atmosphere from 1150 light years away. In 2022, James Webb analyzed an exoplanet called WASP-96b and found unmistakable signature of water vapor in its atmosphere, the most detailed atmosphere reading ever taken of a planet outside our solar system. Now WASP-96b is not habitable. It is a hot gas gained to the surface temperatures over 530 degrees Celsius. But that discovery proved the technical works. James Webb can detect water, it can detect oxygen, which means it can, in theory, detect the specific combination of gases that would induce biological activity on a planet. Some of the James Webb trending images are not of a distant galaxies or aliens' atmosphere. They are of our own cosmic neighborhood, and they show something nobody had ever seen this clearly before. Stars being born, and stars dying. The Pillars of Creation, first photographed by Hamill in 1995, are towering columns of gas and dust in the Eagle Nebula, about 6,500 light-years from Earth. Hubble's image was iconic, breathtaking. James Webb's image of the same structure made Hubble look like a roughly stick. James Webb's infrared vision cut through the dust clouds so that Hubble couldn't penetrate, revealing thousands of newly forming stars inside those columns. Stars in the process of being born right now, each one potential solar system, each one potentially hosting planets. James Webb has a planned operational lifespan of at least 20 years. It has been operational for less than 3 years. In those 3 years, it has found galaxies that shouldn't exist, detected potential biosignatures on a planet 120 light years away, revealed thousands of newborn stars hidden inside cosmic dust clouds, and forced scientists to reconsider fundamentally assumptions about how the universe formed. That in 3 years, 17 more to go, the most anticipated target on James Webb, just 40 light years from Earth. Particular next door in cosmic terms, there were 7 Earth-sized planets orbiting a small cool star. 3 of those planets sit in the habitable zone. One of them, TROPICS 1e, is considered by scientists to the most Earth-like planet ever discovered. 91% of Earth radius, 77% of Earth mass, 93% of Earth gravity. James Webb is already conducting detailed atmosphere analysis of these planets. Results are expected in the coming years. If James Webb detected the right combination of gases in those atmosphere, carbon dioxide, methane, oxygen, water vapor, it would be the most scientific studied discovery in human history. There are approximately 300 million potentially habited planets in our galaxy alone. We have analyzed the atmosphere of fewer than 20. We are at the very beginning. The James Webb Space Telescope cost $10 billion and 25 years of work. It is the most expensive scientific instrument ever built, and in just 3 years, it has already been worth every single dollar, every single day of work, every moment of 25 years it took to build it. We spent thousands of years looking up at the night sky and wondering, are we alone? Is there something out there? What is all of this? For the first time in human history, we have a tool capable of answering those questions, and the answers are just beginning to come in.